Hello, I'm Tamás Lovas from BME, and this is the Capturing Reality module, and this time we will talk about terrestrial laser scanning. So we'll talk about first what laser is, then what kind of terrestrial laser scanners can be used, and then some words about TLS surveying and TLS data processing. The TLS use cases, however, will be discussed in a separate video. So laser is a light. Laser is very focused, high energy light. So usually the lasers, what we are used in mapping technologies in laser scanners, are working either in the visible range or in the near infrared range. So the visible range is from 380 to 750, 60 nanometers. The near infrared and infrared range, what we have laser scanners are using, there are 1 micrometers, 1.5 micrometers, 1,500 nanometers. So there are different colors of lasers, but since they are very close to the visible range, it can be considered that if you can see through, for example, rain or fog or very light cloud, the laser can go through. Otherwise, it can't. Okay, what kind of laser scanners will we have? How can we make difference between laser scanners? There are different size of laser scanners. The newer scanners are very, very small. They can fit in even in a backpack. You can put in your carry-on baggage on an aircraft. They are different in case of operation. You can operate them on a touch screen or from a mobile phone or from a tablet. They have different resolution, but there is, I think, we didn't reach the limit, but we don't need higher resolution what the current use laser scanners can do. In case of range, there is a big difference. There are many scanners that are capable of capturing data within only 100 meters, but there are higher range laser scanners to be able to capture points from 6 kilometers, even 6 kilometers. There's a big difference in price from some 10,000 euros to some 100,000 euros. Speed depends on the distance measurement speed and whether we are collecting images or not. We will discuss it later. And there are also laser scanners capable of on-site registration. So the main point is how robust is a scanner on site. But the main principle of or the concept of terrestrial laser scanning is pretty similar to that of total stations. So we are measuring horizontal and vertical angles and distances, like in case of a total station, but we are measuring multiple, like even 1 million points per second, and we are capturing the entire surface of an area. Instead of directing certain points, particular points on site, we are capturing the entire surface, the visible surface. So in case we want to capture the geometry of a house, we need to go around it and capture it from different scan stations, and we need to register this point cloud. We need to merge this point cloud, and we can use certain targets, what you can see on the lower left corner, like a sphere or a checkboard sign, and we need to combine to merge this point cloud and deal with the combined point cloud. In the pre-processing phase, we are doing this registration and georeference the data. If we have not only common points, but so-called ground control points, these are points what we have coordinates in the point cloud, and we have also geodetic coordinates. Then we can georeference this data. We can do resampling. Often we are collecting more dense point cloud what we need, so we can resample it. We can omit many of the points, and we can export it to the required format. In case of the processing phase, we are creating some kind of MPRODEC, for example, for architectural purposes. We are deriving 2D vector data. We can derive surface models like mesh data, or solids like bodies of the object geometry, or we can use the point cloud itself, or we can derive orthophotos if we are capturing images in the same time. We need to use multiple softwares, and in many cases we need to split the data sets and only work only part of them, because this is about big data. There are different concepts of distance measurements with laser. The most obvious one is the time of flight. When we are emitting a laser beam and it reflects from the surface, and since we know the speed of light, we can measure the velocity. Then with the speed of with the speed and we can measure the time, and with the speed and the time we can compute the distance. So that's easy. So this method enables 4 to 5 millimeters of ranging accuracy and higher ranging distance. On the other part is the other method is the phase-based system, when we are measuring the the phase shift of the reflected signals. That's not an easy task because we need to modulate the amplitude of the waves emitted and reflected. But that enables, many scanners are using that, much higher accuracy, 1 to 2 millimeters of ranging accuracy, but at a bit lower measurement range, like 1 to 300 meters. So if you want to check a particle scanner, check the technical specification on the website of the scanner, and you will find the ranging accuracy, the range noise, or even the angular accuracy for different scanners. I collected some text spreads here to you. Okay, in case of the tools, we need tools for pre-processing and processing. There are vendor software, for example, for Farosyn for the Faro scanner, Leica Cyclone for the Leica scanners. There are generic software, for example, Autodesk Recap or Cloud Compare, so widely and generally used point cloud processing software. But if you want to make the product from the point cloud, you need a modeling software like the BIM software, Revit or Archicad, or DesignX for more sophisticated point cloud definition, or for different applications, even like road construction or railway construction, you can use Civil 3D from Autodesk. Okay, if you want to evaluate the terrestrial laser scanning technology, the main advantages are day and night. They are working day and night and indoor measurement. Obviously, we don't want to work in night, but still we don't capture the reflected light, but we are emitting a laser signal and capturing its reflection. So it works day and night. Therefore, it's not sensible to shadows and sunshine. We can capture colors information with cameras. Usually they are built in the laser scanners, and we have a scalable resolution. A typical resolution for engineering survey is 3 to 6 millimeters between the points. That's the point spacing in 10 meters distance. The disadvantage on the other side is the huge amount of data. So we need processing performance, and we need some kind of resampling. In many cases, we have just too many points what we need to collect, and we want to get rid of some of them, so we are resample the data. And obviously, there are occlusion problems during the data capture, so we need to design the data capture on site in order to avoid occlusions. So I collected the references against some books and some web links, so feel free to check it. And thank you for your attention. The next video will be about TLS, terrestrial laser scanning use cases. I want to show you its potential through applications. Thank you very much. See you next time. Goodbye.